Hello everyone. In the last video, we have seen that what happens when we connect a ammeter in parallel instead of connecting it in series, and what happens when we connect in series the voltmeter instead of connecting it in parallel. Now we will dive into one more question, that why we actually design the ammeter with low resistance and the voltmeter with high resistance. See, ammeter is usually used to measure the current. If we design the ammeter with low resistance, if we design the ammeter with high resistance instead of designing with low resistance, if we design with high resistance, as it is connected in series to the load, if the ammeter resistance is high, it will add to the resistance of to the load. Means the resistance of ammeter is added to the resistance of the load, so that the current flowing through the load will be changed. That's why when we connect an ammeter which is having high resistance in series to a load, it will disturb the circuit. It will alter the conditions of the circuit. That's why we will not design the ammeter with the high resistance. Similarly, the case with the voltmeter, if we design the voltmeter with low resistance. Actually, the voltmeter is connected in parallel to the load in order to find the potential difference across its ends. Now, if the voltmeter resistance is lower, the current always chooses a low resistance path. So maximum amount of current will flow through the voltmeter but not through the load. So we cannot measure potential difference across the load properly because it is disturbing the circuit operation. It is disturbing the circuit operation. Hence, we design the voltmeter with high resistance. Now the next question is how we are able to make the voltmeter a low resistance instrument. Basically, ammeter and voltmeter are moving coil instruments. Inside these instruments, there are some coils, and these coils has some resistance. Now, in ammeter, let us say in ammeter, so this is the resistance of the coil. Okay, what we will do in ammeter is we'll connect a very small resistance which is called as shunt parallel to this coil. So when we connect a small resistance RSH parallel to RC, the resultant resistance reduces. Is it right or not? In parallel combination, the equivalent resistance is less than the least. That's why the equivalent resistance of RSH and RC will be very much lesser. By this we can make the ammeter, means with this method we can make the ammeter a low resistance instrument. Now coming to voltmeter. Voltmeter, I want to design the voltmeter with high resistance. What we actually do is, voltmeter also has a coil, a moving coil. Its resistance is RC. We'll just connect it to a very big resistance in series. Means a very big resistance is connected in series to the coil resistance, so that the next resistance now will be increased, because we know that in series connection the equivalent resistance is larger than the largest. So in voltmeter, by connecting a large resistance in series to the coil, we can increase its resistance and make it a high resistance instrument. In ammeter, by connecting a very small resistance which is RSH in parallel to RC, we can make the ammeter into a low resistance instrument. The reason why we are making voltmeter a high resistance instrument and the ammeter low resistance instrument is not to disturb the operation of the circuit. I hope this video gave you some idea about why we are making the ammeter with the low resistance, and why we are making the voltmeter with high resistance. Still, if you have any doubts, please post them in the comment section so that in my free time we'll try to answer those questions. If